G'day, my name is Brennan Gregg. This is a quick talk on the DTrace book, which I wrote with Jim Marrow and was released this year. DTrace is a performance analysis and troubleshooting tool that's available for Solaris-based systems, Mac OS X, and FreeBSD. The book has lots of example scripts inside, which you can download from DTraceBook.com so that you don't have to type them all out. In this short talk, I'm going to give you a quick rundown on what DTrace is and also what's inside the book. DTrace can be used at the command line, and so some people use DTrace by running scripts like IOSnoop, which is a popular tool on Mac OS X. That snoops disk I/O live. You can also use DTrace by writing custom one-liners, and DTrace has a very powerful and rich syntax. This is frequency counting system calls. And you can also go and write multi-line scripts that do very advanced things. You may also be using DTrace from some higher level tools. This is Cloud Analytics from Giant. It's showing file system latency as a heat map. And some of these tools we do have an emphasis on heat maps because DTrace gives us a rich set of data. It's able to give us the full distribution of important metrics like latency so that we can examine outliers and the full distribution. So there's system call latency, heat map, various other ones. Various other tools that are also based on DTrace, just in case you've seen these before. So you might actually be using DTrace already and not being aware of it because you're using it from one of these higher level tools. What's in the book? We've got a chapter for Introduction to DTrace, which is important because one of the difficulties with DTrace is just getting your head around what it is. It's quite different from other tools. There is a chapter on the language of DTrace, D. This summarizes DTrace very concisely. There is actually a language reference that's online that's freely available as a PDF. It's 400 pages. So we didn't need to replicate that. We've summarized it concisely, which may be great if you already can program in some other languages as it goes quickly through the things you need to know. The D language itself is similar to C and awk. And that chapter ends with some example programs. Chapter 3 is System View. For this chapter, what we've done is we've described to a system administrator audience, in particular, how DTrace can extend the existing toolset and methodologies. And we talk about the methodologies there. If you've read one of my previous books, Solaris Performance and Tools, this is a logical extension of that. And that can be useful because we're building upon what people already know, some of those performance tools, and showing how DTrace can go further. Chapter 4 on disk I/O, this is really where we're just doing DTrace. This is for everyone. And the model of chapter 4 is how many of the subsequent chapters go. We describe the topic. Here's a functional diagram that talks about disk I/O. I love these things. You can go through functional diagrams. This is showing how a disk I/O is issued, how the interrupt completes. And you can use them as a checklist to make sure that you've checked everything, you've examined the latency and the error paths that you need to, and leave no stone unturned. We have a section on strategy. There's more steps than that. A checklist section, because listing out strategies and providing checklists is a very important aspect of the book. The book is not just a big cookbook full of scripts. It does have a lot of scripts. We also put a lot of effort in showing the strategy and getting into the mind of using DTrace so that you can roll your own scripts. There's a section on one-liners, usually about a dozen for each chapter, and some examples of using the one-liners. This one's doing disk I/O when it's being issued and showing the kernel stack backtrace so that you can get an idea of what type of disk I/O that is. Then in the chapters we've got sections on scripts. So for the disk chapter, we've got scripts that look at disk I/O, SCSI, I/O, SATA, and IDE and SAS. And this is really one of the powerful aspects of DTrace, is that you can go through different levels of the kernel and look at I/O events. I might want to look at errors. I might want to look at latency. And that really is helpful for finding bugs and also finding performance issues, because errors can happen anywhere inside your complete operating system stack. And so with DTrace, you can inspect all of it and narrow it down. And then the rest of that chapter, we've got examples for the scripts. We explain them. This one is germ IOSnoop for FreeBSD. The script listing, which again, you don't need to type this out. It's on DTraceBook.com. And then examples of using the scripts explained. Here's one of my favorites from the disk chapter, SCSI-RW.D. This was written in particular because these days we're seeing a lot of performance issues based on the latency of the SCSI flush cache command. And the SCSI flush cache command is one of those meta commands not normally incorporated into the reads and writes that you see through tools like IOStat. So if you're using the normal IOStat tool, I don't even know that my operating system and my applications are suffering latency due to this SCSI command. So since DTrace can trace everything inside the kernel, it's not too hard to write a script to give us details on that. So lots and lots of scripts in Chapter 4, and a lot of them are very short, so you can take them and customize them for your environment. Chapter 5 is on file systems, and the scripts in there, again, the previous sections, it does have strategy and checklist and diagrams and one-liners. The script groups, we've got file system observability via the syscall layer, via the VFS interface. We've got scripts for UFS, ZFS, HFS+, PCFS, HSFS, UDFS. These are all great, and what it's doing is for a lot of application issues where they may be rattling the disks, we've found it extremely useful to look at latency at the file system interface instead of at the disks, because it's the file system interface that the application is waiting for. Disk I/O can happen asynchronously to the application. So you actually care much more about measuring it right next to the application. And of course, we can drill right down deeper and deeper to narrow down and to focus on particular issues or the origin of latency. So one of my favorites is HFS Slower.d. There's a ZFS Slower.d. You give it a millisecond argument and it shows the I/O that were the file system I/O that was longer than that millisecond as a quick way to focus on slow I/O. And it's showing you the process name and some details about the file that was being accessed. Chapter 6 is on network lower level protocols, such as TCP and IP. Again, whole heap of sections that I've skipped, like before. There's strategy, there's checklists, one-liners. For scripts, there's scripts for socket, tracing, IP, TCP, UDP, ICMP, XDR, and Ethernet. And so really the full stack, you've got examples of using DTrace to get information from all of them. Some of my favorites include the socket scripts. So a previous project that I still maintain is the DTrace Toolkit, which has over 200 scripts for looking at various aspects on the system. One thing I didn't do a lot of at the time was socket-based tracing, and I've caught up with the DTrace book. So SO Connect is an example of that. Here it's looking at an mmap port scan. It's showing you the address, the port, the latency, and the result. And that's just pulling it out of the socket layer. Loading a website, first byte latency, printing out the first byte latency in microseconds, another favorite of mine. And there's also lots and lots of other scripts. That's a TCP Connection latency script showing distribution graphs in nanoseconds. Right down to the device. So this is looking at E1000G network driver and showing the lower level kernel path taken. So again, emphasizing that DTrace can look throughout the operating system stack, get detail where you want. Chapter 7 is on application level protocols. And the scripts inside this chapter include scripts for NFS, v3, NFS v4, CIFS, HTTP, DNS, FTP, iSCSI, Fiber Channel, SSH, NIS, and LDAP. So quite a lot of example scripts that you can take, customize. And there's too many scripts for me to go through in this short video. Chapter 8, languages. has scripts so that you can examine higher level languages themselves, which is also part of examining applications. And we go through assembly, C, C++, Java, JavaScript, Perl, PHP, Python, Ruby, Shell, and TCL. Applications. Doing application analysis has already mostly been covered at this point in the book through chapters like the disk chapter, the file systems chapter, the network chapter. This covers things that the previous chapters missed out on and ties them together. We've got a chapter on databases where we go through detracing MySQL, Postgres, and a little bit on Oracle. A chapter on security, so using DTrace for security purposes, such as monitoring, policy enforcement, security debugging, sniffing. And there's a chapter for the kernel as well, and some really great tools in there if you're interested in how the kernel works. There's a chapter on tools, which goes through some of the high-level tools that have been built upon DTrace, which includes Chime, DTrace GUI for NetBeans. There's also Mac OS X Instruments uses DTrace, and the Sun Storage Analytics uses DTrace, and a chapter on tips and tricks. There are several appendices, DTrace tunable variables, and some other things that are really handy to have a printout of to look up when you need it. So that's what's in the DTrace book in a very, very quick video. It's over 1,000 pages, so I can't show you everything that's inside the book in a few minutes, but that might give you a taste. Do check out the website. There's a sample chapter on there that you can read for the file systems. You can also check out my blog, dtrace.org/blog/Brendan, and I frequently post about DTrace and using it, especially these days for cloud computing. And of course, check out the website for dtracebook.com. Thanks for watching.